Hello everyone, this is Feng from Waseda University. It is my honor today to present you with our paper, 360 Depth Estimation in the Wild, the Depth360 Dataset, and the SegFuse Network. By providing a comprehensive view of the environment, omnidirectional images are useful in a wide range of fields, such as robotic navigation and virtual reality. In this work, we propose a method to estimate high-quality depth map from a single omnidirectional image. With the ability to estimate the distance between objects and the point of view, we can better accomplish tasks that require a good understanding of the scene, including autonomous driving and 3D rendering. Previously, there is no existing omnidirectional dataset that includes dense depth maps for outdoor scenes due to physical restrictions of imaging devices. An existing method designed for only indoor scenes shows bad performance for an extended domain of scenes. In this paper, we achieved depth estimation in the wild through repurposing 360 internet videos. We first proposed a test-time training method for generating a large-scale dataset, Depth360. We then present a multitask network to take advantage of the dataset by mimicking the human eye. While infrared-based sensors are efficient in capturing depth, they are ineffective to capture in a lot of situations, such as outdoor scenes. Alternatively, synthetic samples suffer from domain gaps when applied to real-world situations. Recently, there are LiDAR-based datasets being released. However, these datasets are solely gathered for autonomous driving and have extremely limited scenarios. In this work, we first tackle the problem of limited datasets by exploring the abundant source of data, 360 videos from the internet. We first pre-process successive frames from the video sequence to establish quality frame groups that facilitate computing constraints of the sequence. We then propose novel temporal and geometric consistencies that are unique to 360 videos with a horizontal spherical disparity model. We use test-time training to iteratively fine-tune a pre-trained model to satisfy the established constraints before generating depth maps. Here are some videos we used in this work. And here are the corresponding depth maps generated using the proposed test-time training method. Here are some samples in our large-scale omnidirectional dataset, Depth360. It includes 30,000 high-quality samples with a wide range of conditions. The dataset is available from the link in the paper. To take advantage of the dataset and account for challenging scenarios with different depth scales, we propose an end-to-end two-branch multitasking network called SegFuse. The upper peripheral branch regresses depth maps with equirectangular projection, resembling humans' peripheral vision to perceive depth. It is capable of capturing global context with distortion and with a larger FOV. The lower foveal branch estimates semantic segmentation with cubemap projection, mimicking foveal vision to distinguish between different local objects. This branch provides sharper boundaries for local objects but introduces inconsistency between faces. By fusing two branches with each other, our network combines the advantages of more consistent global context and sharper local details. Here, semantic segmentation and depth estimation are jointly learned to review the scene layout and object shapes. While the peripheral branch enforces more consistent estimation, the foveal branch is more robust to scale changes which frequently appear in outdoor scenes, and hence, this method can successfully take advantage of the proposed, a more general dataset. For more details regarding loss functions for training the depth estimation and semantic segmentation, please check out our paper. Here are some qualitative results of the proposed single-view estimation. It is worth mentioning that our method is proposed to estimate depth from single views, considering it is more convenient and practical to gather images in real-world applications. Therefore, some flickering caused by inconsistency across frames will happen. When qualitatively compared to previous methods, we can see that our method shows less artifacts and sharper details at local regions. We quantitatively evaluate our method on datasets that respectively incorporate real samples and synthetic samples to verify that it outperforms state-of-the-arts both in real and synthetic domain. To showcase the applications of our single-view depth estimation method, we have implemented some demos with Unity 3D. Based on a synthetic input, by estimating the depth of this view, we can render different visual effects with correct occlusions and simple scene interactions. For example, snowflakes bouncing off the ground. Here is an example of using a real-world image as input. We can see that our method did a relatively good job separating the foreground and some basic geometry of the background, aka the environment. Finally, we have some demos when testing our applications on randomly collected 360-degree images from the internet. In summary, in this work, we propose to utilize 360 videos in the wild to generate a large-scale dataset, Depth360, to solve the unavailability of a general dataset. We then propose an end-to-end multitasking architecture called SegFuse that estimates depth from a single 360-degree image. By fusing the global context and local details, our design ensures a sharp and consistent depth prediction. We showcase improved performance with extensive evaluation against state-of-the-arts, and to encourage future research, the datasets, source codes, and models are made available to the community. Thank you for your attention. If you're interested or have questions, please don't hesitate to contact me.